we're asked to evaluate the given definite integral. To integrate, we will have to perform u substitution, and this integral is more challenging than most. Looking at the integrand function, we have x cubed times the square root of the quantity x squared plus 15. Normally when performing u substitution, we let u equal the higher degree part, meaning we would typically let u equal x cubed. But in this case, this is not going to work. And let's find differential u to see why. Differential u is equal to 3x squared dx. If we divide both sides by 3, we have 1/3 differential u equals x squared dx. Now looking back at the integral, notice how we don't have x squared dx. We have x cubed dx, and the x squared is attached to the 15 by addition under the square root. So this u substitution is not going to work. So let's try u equal the quantity x squared plus 15. If we let u equal x squared plus 15, then differential u is equal to 2x dx. If we divide both sides by 2, we have 1/2 differential u equals x dx. Now looking back at the integral, we might be thinking, this doesn't work either because, again, we have x cubed dx, not x dx. But if we look back at this first equation, u equals x squared plus 15, if we solve this for x squared, we can use the new equation and this last equation to perform u substitution. So to solve for x squared, we would subtract 15 on both sides, giving us x squared equals u minus 15. So again, now we'll use this first equation and this last equation to perform substitution for x cubed dx. To better show this, let's rewrite the given integral. Let's write this as the integral of, let's write x cubed as x squared and then x dx. Let's write the square root using the rational exponent of 1/2. So we'd have the quantity x squared plus 15 raised to the 1/2. Now looking back at our equations, we will substitute u minus 15 for x squared. We will substitute u for the quantity x squared plus 15, and we will also substitute 1/2 to u for x dx. Performing the substitution, we have the integral of, again, x squared is equal to the quantity u minus 15. X squared plus 15 is equal to u, so we have times u to the 1/2. And x dx is equal to 1/2 to u. So let's factor out the 1/2, and we have differential u. Next step, let's distribute the u to the 1/2. Remember, u is the same as u to the first. This is equal to 1/2 times the integral of u to the, when multiplying we add the exponents, 1 plus 1/2 is 1.5 or 3/2. So we have u to the 3/2 minus 15 u to the 1/2 differential u. And now we integrate with respect to u. This is equal to 1/2 times the integral of u to the 3/2 is u to the 3/2 plus 1 is 5/2. So we have u to the 5/2 divided by 5/2 minus 15 times the integral of u to the 1/2 is u to the 1/2 plus 1 is 3/2. So u to the 3/2 divided by 3/2, and of course plus c. And now let's simplify. This is 1/2 times the quantity. Dividing by 5/2 is the same as multiplying by 2/5. This is 2/5 times u to the 5/2 is really the quantity x squared plus 15 to the 5/2. And then we have minus 15 dividing by 3/2 is the same as multiplying by 2/3. And u to the 3/2 is really x squared plus 15 raised to the 3/2. And now let's distribute the 1/2. 1/2 times 2/5 is 1/5. We have 1/5 times the quantity x squared plus 15 raised to the 5/2. So let's simplify before multiplying here. There's 1 3 and 3 and 5 3s and 15. This is 5 times 2, which is 10. 1/2 times 10 is 5. So we have minus 5 times the quantity x squared plus 15 raised to 3/2 plus c. So typically, I would leave the antiderivative in this form here, But let's also show how to factor this by factoring the quantity x squared plus 15 raised to the 3/2 power from these two products, because this might be the form shown as the antiderivative in the back of a book or in your online homework system. So we'll factor the quantity x squared plus 15 raised to 3/2 from both products. So factoring this out of the first product, we have 1/5 times the quantity. If we factor the quantity x squared plus 15 raised to 3/2 out of the quantity x squared plus 15 to the 5/2, we're left with the quantity x squared plus 15 raised to the 2/2 or first power. So we can leave the exponent off, and then we have minus. If we factor this quantity from the second product, we're left with just minus 5. And now let's distribute the 1/5 here. So we have 1/5 x squared. 1/5 times 15 is 3, so we have plus 3 minus 5. And 3 minus 5 is equal to negative 2. This simplifies to the quantity x squared plus 15 raised to 3/2 times the quantity 1/5 x squared minus 2 plus c. This is another way to express the antiderivative, but we can also factor out 1/5 here. Let's go ahead and show that. If we factor out 1/5, this factor would stay the same. And now if we factor out 1/5 from 1/5 x squared, we're left with x squared. If we factor 1/5 out of 2, we're left with 10, so we have minus 10, and then plus c. And just checking this, if we distribute 1/5 into the second binomial, we do have 1/5 x squared minus 1/5 times 10, which is minus 2. So some sources may give this form for the antiderivative. I hope you found this helpful.